So here's just kind of a little bit of a walkthrough. I know I put up an answer key, but this is kind of a walkthrough of our different theorems and how we're kind of going to be using those. So for this problem, you're looking at this and you're like, okay, I've got two angles inside of a triangle. The theorem that we're most used to is the triangle sum theorem, which just says we know inside of a triangle, if we have all three angles inside of a triangle equals 180. This would be an example when we have an angle that's stuck on the outside, so out here. This is called our exterior angle theorem. That theorem says our two remote, or essentially angles that aren't adjacent to our exterior angle. So our two angles that are further away from our exterior angle added together will equal our exterior angle. So what that means for us is then I can do my 44 plus my 18x minus x minus 3, and I can set it equal to the number or equation on the outside. Okay, so again, exterior angle theorem tells us our remote interior angles add together to equal our exterior angle. So then from here, this is just kind of our solving. Our 44 and 3 gets me 41 plus 18x equals 6 plus 25x. As we're solving, I subtract the 6, so we get 35 equals, I would subtract the 18, and that's where we get our 7x over here. Divide by 7, so we get x equals r5. Okay. So again, as we go through these slides, it's just kind of the general idea of using these two different theorems to find our different angle measures. Okay. So again, I look at this problem. I look inside my triangle. I only have two angles, so I can't be adding them all up and equal to 180. And then I'd say, okay, well, I do have an exterior angle. So is it exterior angle theorem? Exterior angle, the two interior angles are further away. They're not right next to that. So we have exterior angle theorem. So same thing here. I can say these two remote interior angles add together. So I can say 76 plus 1 plus 5x equals our exterior angle, the 12x plus 14. And we go ahead and solve it. So here I get 77 plus 5x equals 12x plus 4. Subtract the 5 over here, we get 7x. Subtract the 4 to the other side, so we get 73. Again, this is all our solving piece. Oops, sorry, not 73. Let's see. Was it 77? Oh, 14. Sorry, I wrote a 4, not a 14 there. So we subtract that. That gets us 63. Then we divide by 7. So we get our answer, x equals 9. Okay. The initial setup is the part that is the most important. Most of you are doing somewhat okay with our solving piece, so that's not super concerning. But again, that's kind of the main part, is just setting this up. Okay. So we'll continue going through. Like I said, I'm going to go through these to make sure, and as you go through this, you can kind of speed through if you want to see which problems you have questions on. Again, here I look inside my triangle. I don't have all three angles, so I'm not going to be adding them up and putting them equal to 180. So it's not my triangle sum theorem. So I do have an exterior angle out here. The two angles inside, our interior angles here, are our remote ones because they're not right next to that 80. So I'd have my exterior angle theorem. Again, it says my remote interior angles added together. So 19x plus 2 plus negative 2 plus 21x equals 80. Again, it's not 180 because it's not the three inside angles, so we're not going to put it equal to 180 there. Our 2's here cancel out. 2 minus 2 gets me 0. So 19 plus my 21 gets me 40x equals 80. You divide by 40, so we get x equals 2, which is awesome. But again, in this case, make sure you're looking to see what they're talking about. They say find angle ABC. So angle ABC, again, we look at the middle term. So B is my middle value, or my middle letter there. So B is the angle we're actually looking at. So I would plug this 2 back in and do 19 times 2 plus 2. So 19 times 2 plus 2 would end up getting me 40. So I know ABC is 40 degrees. Okay. Again, exterior angle theorem, an angle on the outside, two remote angles on the inside. All right, so here's one where I'm looking again. The first thing I like to look for is, again, do I have all three angles inside of my triangle? In this case, I do. So if we have all three angles inside of my triangle, we know this thing's going to equal 180. So I'm going to say, well, all those things added together should equal 180. Again, I know it's equal to 180 because it's the three angles inside of my triangle. So x plus 3x plus x gets me 5x plus 15 equals 180. When you subtract the 15 from both sides, you get your 165. And then when we divide here, we get x equals 33. Again, x is all they're asking for. So I have my answer of x equals 33. Okay, triangle sum theorem, all of our angles inside the triangle add up to 180. So that's our set here. Another one, all three angles are given to us inside of my triangle. So I would just be adding all of them up and putting them equal to 180. So again, I'm just adding all three of my angles together. So x plus 3x plus 2x. Again, this one will get me 6x. When I combine my numbers here, 40, negative 17, negative 5, we get plus 18 equals our 180. When we subtract the 18 to the other side, we get 162. So I'd end up with x equals 27. Again, they're only asking for x. They didn't ask us for an angle, so I'd be okay there. Here's one that's a little bit more unique. So initially I'm looking at this and I'm like, I don't have exterior angle theorem. I don't have triangle sum theorem. The reason why I don't is I have an exterior angle over here. Well, not really an exterior angle. It's on the outside. It's not even like right next to my triangle. Same thing with 70. It's not right next to. It would have to be right where A is, right where C is, or over here for that thing to actually work. Okay. So right now we don't really have anything at all. But we do know if this is 70 here, then this other piece here has to be congruent because of vertical. We know vertical angles are congruent, so I know in here we have a 70. Same thing over here, I can say, well, this and this are also vertical. So then I could write 13x plus 6 inside of here as well. And now I have all three angles inside my triangle are known. So I can say, well, this has to be my triangle sum theorem. So I would do my 8 plus 3x plus 70 plus 13x plus 6 equals 180. Again, all three angles inside my triangle have to equal 180. So here when I add all of this up, we end up getting 16x plus 84 equals our 180. And then when I subtract the 84, we get 16x equals 96. Divide by 16, and we get x equals 6. Again, up here, they're asking us for a specific angle. They say angle ABC. B tells me I'm looking at my angle up here on top. So I would plug my 6 back in, so we'd have 8 plus 3 times 6. So 8 plus 3 times 6 is 18. So we add those together, we get 26 degrees for our angle. Okay. Again, this one you had to move some things around a little bit to get to our triangle sum theorem. This is more of like the kind of critical thinking that you're going to be expected to do on a quiz or a test. All right, so this problem here, again, I don't have all three angles inside of a triangle, but I do know here I have a vertical angle that it can kind of move something into my triangle. So I'm going to go ahead and do that and say, well, those are vertical, so I know this is now 19x plus 4. Right now I don't have all three angles, but I do have an exterior angle. Again, it's right on the outside of my triangle here. And it's remote interior angles. So this would be an example of one that I could do exterior angle theorem. Some of you are like, well, Mr. Schultz, I would subtract this from 180 to get this 70 over here because it's a linear pair, they're straight line, and then do my triangle sum theorem. That's fine. Again, I'm just going to use the theorems as much as I can to kind of show you as we go through this. So here I'd have 110 is my exterior angle. Remote interior angles are 19x plus 4 and 8x minus 2. So here I'd have those two added together equals my exterior angle, which is 110. Again, a lot of us that I've been seeing have been putting things equal to 180 pretty much every time. Again, I only put it to equal to 180 if it is a linear pair where they're right next to each other and they make a straight line, or when you have all three angles inside of your triangle. Since there's not all three triangles and I'm not kind of getting this little left open spot, we're not going to put it equal to 180. So here I would go through and add, again combining my like terms, 19 and 8 get me that 27. X, 4 and negative 2 get me plus 2 equals my 110. We continue solving, we subtract the 2, so we get 108. And then when I divide both sides by 27, we get 4. Okay. Again, I look back up here. Is that what they asked me for? Nope. They asked me for a specific angle. So I look for, again, ACB, C being the actual letter I'm looking at. So C is this angle down here. So I would do 8 times 4 minus 2. 8 times 4 is 32 minus 2 equals 30. So again, 30 degrees would be my answer. All right, moving right along. Again, another kind of funky looking problem. So I look initially, I have two angles here, I don't have a third angle. I have two angles here, I don't have a third angle, and I'm looking for this piece here. So for this one, I'm going to be using my triangle sum theorem a couple times to get myself to x. Okay. I have these two angles here, so if I have two of my angles inside of a triangle, I can find this other one. I'm going to call it y. You don't have to really call it anything if you want, but you just need to know I should be able to find this other little angle down here. Okay. So I have 50 and 80, and I don't know y is, but I do know together all three of these should equal 180. So I could start by writing that one out as 50 plus 80 plus y equals 180. 50 and 80 get me 130. Subtract the 130, so we get y equals 50. So I know this angle right here is 50 degrees. Okay, so that's found one part. For me to figure out what x is, I would also need my other piece over here. So I'm going to change colors so this isn't kind of all in the same thing. Again, I got 65 here, I've got 90 here, so then over here I'm going to call this z and say we're going to try to figure out what z is. Okay, so I've got 65 plus 90 plus z equals, again, 180. I know it's equal to 180 because we're dealing with three angles inside of this big triangle here. Okay, so 65 and my 90, when I add those together, we get 155 plus angle z equals 180. I subtract the 155, so we end up with z equals 25. So I know right here we have 25. Our goal here is to end up with x. So again, I now have a little baby triangle here that I know two of its angles, so I should be able to find the third. Again, because inside of a triangle, all three angles have to add up to 180. So I would do 50 plus 25 plus x equals 180. Again, it's only equal to 180 because I have three angles inside of a triangle that we're saying has to equal that 180. If I add those together, we get 75 plus x equals 180. When I subtract, we get x equals 105 degrees. Okay. Again, might take a couple more steps, but we're still using the same two theorems. Exterior angle theorem we did not use this time, but we did use our triangle sum theorem a couple times with this problem. Okay. Last two. So here, I'm looking at this, and I'm like, okay, I've got a bunch of information. I just start with whatever angles they give me and kind of move from there. My goal is to find x. It's on the outside of a triangle, so most likely at some point I'm going to use this exterior angle theorem. I don't have enough information yet because I would need my angle up here and my angle over here for me to be able to figure out using my exterior angle theorem, because those are my two remote interior angles. Okay. So I'm going to go ahead and try to deal with this first little angle up here, 65. So I have 65. I know it's vertical to get to the angle I actually need. So I will put 65 inside here. Okay, so that's one of the angles I need. Now I need this other one with the two markings. I can get there. They tell me this is 90 degrees, but it doesn't tell me exactly what that's going to be. So I do have this triangle on the bottom right, 43 and 92. I know two of its pieces. I'm going to call this little baby angle over here y. So it's 3 angles inside of a triangle. So we're dealing with triangle sum theorem. So I'll do 43 plus 92 plus y equals 180. 43 and 92, if I add those two things together, it gets me 135 plus y equals 180. I subtract that 35 and we get our answer of 45 degrees. So if y equals 45 degrees and this is a 90-degree angle right over here, then whatever's left, 90 minus 45 gets me 45. So I know this angle over here also has to be 45. It was split evenly. Okay. Now we can deal with our exterior angle theorem. I have enough information now to figure out what my x is. Okay, the x is on the outside. It's an exterior angle to this triangle. I have the 2 remote interior angles, so I can say those 2 remote interior angles added together, so 65 plus 45, is going to equal the x on the outside. Okay, again, that's our exterior angle theorem. Says exterior angle is equal to the remote interior angles of the triangle, basically right next to it. So when I add those two together, we get 110 equals x. So I know that that exterior angle is 110 degrees. All right, last one here. I've got exterior angle theorem, triangle sum theorem, again, are the things that we have. We're going through, I have a couple different angles that are given to me. My goal is to figure out what x is, okay? So to get x, I either need the 2 angles down below within that triangle, or I just need this little baby angle over here, so I can set exterior angle theorem up with the 130 to kind of get to that piece. Okay, so my goal then is to try to figure out eventually what this angle is, so I can use my exterior angle theorem to get x. Okay, there's quite a few different ways you can do this, but this is just kind of one way we're going to walk through the problem. I'm going to start over on the left side. I have a 90 degrees over here, so I know this one over here has got to be 90 degrees as well because it's vertical. I know these 2 angles are equal to each other. So now I have 2 of my angles. I've got 40 and 90. So again, inside of a triangle, I'm going to say this guy is y. So I can say 40 and 90 and y should equal 180 degrees because they're 3 angles inside of a triangle. So I'd have 40 plus 90 plus y equals 180. 40 and 90 get you 130. When you subtract 130, we get y equals 50 degrees. So I know y here is 50 degrees. Okay. So my goal here, like I said, is I want to try to figure out my little red angle over here. This is completely your choice. Some people may do this a different way. That's fine. But I know these 2 angles then together, 50 and 60, give me 110. Okay, just because this is one, I'm making this one big old angle here. So I got 50 here, I got 60 here. So I know that this other angle here, or the whole angle, is 110. The line that is created, or basically these angles here, create a straight line together, these 3 angles. So our angle here of 110 and our missing angle over here, which we'll call z, should equal 180 together because they create a straight line. So I can say 110 plus z equals 180. Again, I said the 2 things we're going to put equal to 180 is if we are dealing with 3 angles inside of a triangle or with a straight line. So here we have a straight line. So I've got 110 plus z equals 180. When I solve this, we end up with z equals 70 degrees. Okay, so I know this piece is 70. There's a degree. Okay, so if I have 70, I don't know my x, and I do know the exterior angle, I now have enough information. I'm going to do this one in blue. I now have enough information to figure out what my x is, okay, using exterior angle theorem. Yes, there's other ways you can do this. That's totally fine. Feel free to do so. You could just find out what this angle is and say it's 50, and then add the 3 together and put it equal to 180. Your choice. But right now, with doing the least amount of steps, I could say this is exterior angle theorem. Z and x, we know z is 70. I don't know x, but I do know if I add them together, it should equal 130. So I can say 70 plus x equals 130. Get x by itself, we subtract 70, so we get x equals 60 degrees. Okay. Again, there's a bunch of different ways to solve these. I just gave you guys a few different ways to do this. Continue to ask questions. Let me know if you're unsure about these. Hopefully this video kind of helps out as far as clarifying some of the exterior angle theorem and triangle sum theorem problems. Okay. Please email me or let me know if you need any extra help. Otherwise, have a good one, guys. Thanks.